Hey everybody, welcome. Robert Wolfert here. Welcome to another episode of the series Random Linux Tools Explained. This is all about explaining command line tools you can use for your daily work at the Linux command line. And to make it a little bit more interesting for you, I've added a small challenge for me so that I'm not prepared at all. Instead, I will get a randomly chosen command line tool and then I will do my best to explain this command line tool for you, to show you what this tool can be used for, how you can use this tool, and if there are some things around this tool worth mentioning. Yeah, so let's take the challenge and let's start with sharing my screen. Yeah. Okay, so we are here. Let's go into the directory where all the tools are stored and let's choose the tool I want to explain now, I want to explain today. Yeah, okay, so mixing the tools, and the winner today is MD5 sum. MD5 sum. For the guys joining in later, let's add the tool here to the screen. Now MD5 sum. Yeah, so let's talk about MD5 sum. MD5 sum is a tool that gives you a hash. A hash that shows you, or that can be used to identify, to check the content of a file. So if you have a file, for instance, let's say I have the file hello.sh and then I have some meta information about this file. Yeah, I have the current timestamp, I have the size of the file, and now let's imagine I want to check if the file changes over time. Yeah, I want to check if the file tomorrow has a different content than today. Yeah, so I could tomorrow have a look at the timestamp the file has. Yeah, but the timestamp of a file can be easily modified via the touch command, for instance. Yeah, so if I want to change the file and I want to hide that I have changed the file, then I can simply restore later the timestamp of the file. Let's try this out. Let's try to modify the file. Yeah, let's first make a copy of hello.sh and let's make a copy, call this copy reference, for instance. So now let's create a copy that looks exactly like the original file. Yeah, so I want to have all the meta information. Yeah, reference shall have the same modification time. Yeah, not today, not now, but the same modification time than hello.sh. Now let's choose or let's change hello.sh. Yeah, let's go into hello.sh, for instance. Let's edit it. Let's write not hello world. Let's write hello Robert, for instance. Yeah. So now let's save it. And you see we have a changed modification time. Now let's reset this modification time with the touch command. Yeah, let's call the touch command with hello.sh as a single parameter. And now we have set the current time as the modification time, but let's say I want to set the timestamp to this time of my reference file. Yeah, and I can do this simply by calling touch with -r for reference, and then I have the reference file here. Hello.sh will get the same timestamp as the reference file. So tomorrow I cannot see with the timestamp if the file was modified or not. Yeah. So the second information I have here is the size of the file. Yeah. But I could simply modify the file in a way that the size stays still the same. Yeah. For instance, let's say I modify hello.sh in a way that I write simple hello robot with one single L, and now you see the size is the same, and now the timestamp is the same. ls/l reference the original file hello.sh. Yeah, both files look the same. And if I want to see if they are exactly the same, I could simply have a look into these files. Yeah, but let's imagine these files are huge. These are huge files, and you are looking for some changed bits somewhere within a huge file. So for this, you can use the MD5 sum tool. The MD5 sum tool gives you a checksum, an MD5 checksum, a hash representing the content of the file. So the content of the file as an MD5 checksum from hello.sh. Yeah, the checksum is this one. And if we have a look at a reference file, for instance, then we see we have a different checksum. Yeah, you can say that every file you have on your system has a different checksum, and if you have some modifications within a file, then you can simply use the checksum to check this. Yeah, simply today create a checksum of hello.sh, yeah, write it into a file, a backup, md5 sum.txt, for instance. Yeah, or most of the time, if you see this in a software project somewhere within files, you see files with a name like this, hello.sh.md5, and this then contains the MD5 checksum. Yeah, so now I know my unmodified file has this MD5 checksum, and if later on somehow modifications are introduced within this file, yeah, let's make our modifications, or let's undo our modifications. World, hello world, world, writing and typing at the same time isn't as easy. Then you see, if I call MD5 sum a second time, MD5 sum, yeah, then you see we have a different MD5 sum. Yeah, so the original file in the second example here has this MD5 checksum, the modified file has this MD5 checksum, and so I recognize instantly that this file was modified. Yeah, you can use MD5 sum with every file, for instance, with a larger file, bin ls, for instance, yeah, or bin copy, if you wanna check, or if you want to prove that the ls command, the copy command, will never be modified on your system, just store the current MD5 sum for this. Yeah. There are, for instance, some intrusion detection systems that are based on MD5 sums. For instance, yeah, just as an example, there is an intrusion detection system, an open source intrusion detection system available called AIDE, for instance, or I don't know if this is still open source or some different license. Yeah, Tripwire. Yeah, typically, if you want to implement an intrusion detection system for your local Linux system, and you want to do an intrusion detection based on files, you can do this with AIDE. AIDE will will store, if you call it once, yeah, to seal your system, to seal the state of your system. Call it once, it will write, it will give you a database with all the files within your system with their corresponding MD5 checksums. And then day after day, you can call either with a check or check mode that verifies the stored MD5 sums with the MD5 sums currently associated with the files. Yeah. There is another way for building checksums. Not only MD5 sums can be built, but also SHA1 checksums, just a different algorithm for creating checksums. If you see it, yeah, these checksums are a little bit longer, yeah, if you as you see it here, but the way it works is the same. Yeah. Okay, MD5 sum, SHA1 sum are tools for creating checksums for files or for strings. Yeah, if you have some output of a file, echo hello world, for instance, then you can feed the output of a command. You can feed a data stream to MD5 sum to create a checksum for this feed. Yeah. Okay. So this is the tool MD5 sum. Okay. Let's choose a different tool. Let's choose a different tool. Let's first clear everything. Let's go into tools and let's call choose tool. $h. Okay, so let's mix the tools, and the winner now is Wall. Okay, Wall is a really cool tool if it comes to communicating with other users currently logged into the system. We are now talking about Wall. Wall is a tool that prints out some message you have, for instance, the message hello, to every user that is currently logged into your system. So now every user on a system will get the message hello printed out to the console. You see there's a broadcast message from I'm logged in as the user Wolfhard, and then I switch to the user Robert here, just for convenience, but this is the user who sends original the message, and the message is hello, and the message is from now. If I go to a different console here, I have a different terminal in place. Yeah, you see here that we have received the message. Yeah, so if you are on a system and if you see there are other users on the system as well, and you wanna chat with these users, yeah, you can simply use the tool Wall. Yeah, echo hi there, how are you, Wall, and now not only you get a message, but every other user on the system will get this message too. Yeah, this is the message Wall that can be used for really, really important messages. Yeah, if you want to reboot a system, for instance, yeah, you have done some modifications and you have installed some patches and you want to reboot the system, and you see there are other users logged into the system and they are working. Just send them a message. Send them a message and say, I want to reboot, is it okay? And if the other user knows the command Wall also, then he simply can respond with, yeah, you can reboot, I just log out, or something like that. Yeah. The Wall command, or the mechanism of the Wall command, is also used if you, for instance, initiate a shutdown. Yeah, let's say I want to initiate a shutdown I need to be sudo for this. Let's say I want to reboot the system, and I want to reboot the system in 15 minutes. Yeah. Shutdown -r for reboot plus 15. I want to reboot the system in 15 minutes, and I want to give all the users on the system a warning and time to save their work, time to leave the system. Yeah. And therefore I say I want to reboot in 15 minutes, and then my message system will be back in about 20 minutes, for instance. Yeah. Now let's send this shutdown message to the system, and you see every user on the system now again gets this broadcast message from root at demo. Yeah, because I have called shutdown via sudo to have the proper permissions, and you see the system is going down for reboot, and system will be back in about 20 minutes. This is the message I have given to the shutdown command here. Yeah. So this is the same mechanics you can use with the wall command. Yeah. Okay, so let's cancel the shutdown. Shutdown -c can be used for canceling the shutdown. Yeah, you'll see it here. I don't want to reboot the system really within 15 minutes or in 15 minutes. I want to now cancel the shutdown. And every user on the system gets the information the shutdown has been cancelled. So this is the way the wall command can be used, yeah, to simply print out some data, some messages to everyone. Wall reads from its input data stream. That means if you call wall this way, then you simply have to type in the message you want to send, and if you have entered the entire message and you want to send the message now, then simply send a end of file by hitting Control D. Control D sends an end of file. Now the wall command knows that you are ready for sending the message, and the wall command now sends the message to every console open on the system. Yeah. Okay. So this is the purpose of the wall command here. Let's take the next tool. One more tool for today. Yeah. And the next tool is the tool mixing the tools, and the winner is now modprobe. Okay. Now, modprobe, let's talk about modprobe. Modprobe is a tool for working with kernel modules. If you are on a system, if you are on a Linux system, then you are on a Linux system because the system has booted, has loaded the Linux kernel. The Linux kernel is this binary here. Within boot, there is a binary typically called vm-linux, and let's have a look. And there are multiple versions of the kernel, and you see these files are 6.8, around 7 megabytes in size. So this is the Linux kernel, but not everything of the Linux kernel. And the Linux kernel is since version 2.0 or can be modularized since version 2.0. So you can split the kernel into different parts, store the parts at the disk, and then later on, if you need some functionality from some part of the kernel, yeah, you can simply load these parts. And this loading is where modprobe comes into play. So this is the kernel we see on a Linux system, but only a minimalized kernel. All the other fragments of the kernel are stored as kernel modules within a file system, and these kernel modules are stored within lib modules. Then we have a directory named named after the kernel version. So we have a directory tree 440-11-2020, for instance, AWS. Yeah, this is the directory tree where all the modules, the kernel modules for this version, for this kernel version, are stored. And these files are named with the file name extension .ko for kernel objects. So let's have a look. These are really many files. So let's pipe this output, the output of the find command, to the less command here. And you see these are all the kernel modules within this directory, lib modules 440, and so on and so on. Yeah. So let's have a look how many of these modules are here. Let's count them with WC, short for word count -l. Yeah, just count me the lines, please. And we see we have 800, exactly 800 kernel modules within lib modules kernel version. Let's have a look how big or how much space is occupied by these kernel modules, and you see 44 megabytes. So the kernel, the minimalized kernel itself, has a size of around little bit less than 7 megabytes. All the kernel modules, 800 kernel modules, have a size of together 44 megabytes. So some of these modules are already loaded. These modules are used for device drivers, for instance, file system drivers, for instance, network feature drivers, for instance, the kernel-based network firewall, and so on. Yeah, and if you want to have a look which modules are already loaded, you can use the lsmod command for this. You need to be root? No, you don't need to be root for getting a list of all the loaded kernel modules. Yeah, you see these are all the loaded kernel modules here. Yeah, this is the name of the kernel module, RAID 10, for instance. Then you see the size of the kernel module in bytes. Then you see if the kernel module is used or not. And if it is used, perhaps it is used by a different kernel module. Yeah, so you have some dependencies here within the output. This is lsmod. If you want to remove a kernel module, let's remove a kernel module. Let's remove the kernel module RAID 0, for instance. Yeah, or let's remove the kernel module RAID 0. I don't want to build up an array, an RAID array here. Let's remove kernel module. You can do this as long as the module isn't in use. rm mod RAID 0. Yeah, and now there isn't a RAID 0 module available or loaded anymore. Yeah, so let's remove all the other RAID modules. RAID 10, for instance. I want to remove RAID 10. I want to remove RAID 456, 456. Yeah, and if I have removed RAID 456, then I can simply remove this module. Yeah. Before removing RAID 456, I cannot remove this module because this module is in use by this module RAID 456. 456. Now I can remove it. Sudo rm mod. Let's remove it. Sudo. And you see it works. Let's take a different module that is in use. Yeah, let's take this module and let's try to remove this module, rate6.pq, and you see it cannot be removed because it is in use. Yeah, but I have removed rate 456. It wasn't in use, and therefore I can, or I could remove this file, this kernel module. So, and now let's say I want to load this module again. I need this driver for rate 4, 5, and 6. How can we do this? First, we need the path where the kernel module is stored. Yeah, so let's call find. Let's call find and let's search for the kernel module rate 456.cow. Yeah. So now I have the file. I see this is the kernel module I need to load. Really? Is this the kernel module I need to load? Let's check my current kernel version. uname -r shows me my current kernel version. Okay, my current kernel version is here, the build number 1107 and not 11.20.20. So let's find the right kernel module here. This is the right kernel module, and now I can try to insmod this kernel module to simply load this kernel module, and you know, unknown symbol in module, we will get an error, and it is obvious that we will get this error, just because this module itself needs the help from a second module. In the output here you see from lsmod, you see that async rate 6 recuff is used by, or was used by, rate 456. So if we want to load rate 456 by hand, we just need to load async rate 6 recuff ourselves, and then we can load the second module. Let's try this out. Let's first find the module. Here it is. Now let's load the module. Sudo insmod kernel module. Works. And now we can load the rate 456 module perfectly. And now it works. Let's prove this. lsmod grep rate. And you see rate 456 was loaded, and this module is the base, or is used by this module. So we wanted to talk about the command modprobe, not rmmod, not insmod, not all the other tools here. Now modprobe comes into play. Typically, you don't want to load the modules completely by hand. You don't want to find the kernel modules and then load all the dependencies on your own, or solve all the dependencies on your own. And this is where modprobe comes into play. Let's remove the loaded modules again. Let's remove rate 456, rate 456. Let's remove it with rmmod. And let's remove this async rate 6 recuff kernel module. So now remember, we searched for the rate 456 module, and then we called insmod, and we got an error. So now let's load a module via modprobe. Modprobe, and now only the name of the module. We don't need to know our current kernel version. Yeah, we don't need to find the exact path to our kernel module. We only need to know the name of the module. And modprobe then solves all the dependencies. It loads all the modules our module we wanted to load depends on, and it loads everything together. And then after calling modprobe, we have the module loaded. To see what happens, let's add the -v command line switch for the verbose mode. Without the -v command line switch, we won't see anything. We will only see that the module is loaded. With -v, we see we need root permission sudo modprobe -v rate 456, and you see modprobe itself calls insmod with the async rate 6 recaf module, and then modprobe calls lib modules, insmod with lib modules, and so on for our rate 456 module. So modprobe gives you the option to load a single kernel module without borrowing with your current kernel version, without borrowing with any dependencies. Modprobe does anything for yourself, and you can remove or unload modules with modprobe too. Simply by calling modprobe -r. And then modprobe removes, deloads the kernel module. Let's have a look. lsmod grab rate. You see rate 456 isn't loaded at all. And if you need modprobe sometimes because you have built in a new hardware within your system, into your system, and you need a new kernel module, you need to load it. Typically, you don't need to call modprobe. Typically, there is a service on your system, the hot plug service, the udave service, and this udave service is a hot plug service on your system. Every time the kernel sees a new hardware on your system, a new device on your system, it messages this udave service, and udave service then loads the proper kernel module for this new device, for this new hardware. But sometimes you wanna modify how modprobe loads a kernel module, and if you need this, then you should know that there is a configuration file called etcmodprobe.conf, for instance, or you have single different configuration files within the directory etcmodprobe.d. All these files are configuration files for the modprobe command. And this configuration files, for instance, blacklist some modules so that you can say some drivers should never be loaded on your system, or you want to give some options to some drivers while loading them, and so on. But this is what the modprobe tool can be used for. Simply load a module, not at the command line, just for documentation here. To load a module, call modprobe with the module name. For instance, let's say I wanna load a module for the Intel E1000 network interface. Modprobe E1000. You can give options. I don't know the options you could give. For instance, IRQ equals to, or auto negotiation equals to off, something like that. That could be options, yeah, for the module to load and to deload a module, yeah, to move. Let's see. Let's say you want to deload a module. Yeah, module. You simply call modprobe-r with the name of the module. Yeah, no need for searching the file, yeah, of the module. No need for determining the current running kernel version. Yeah, this is what modprobe can be used for. Yeah, and the other tools here worth mentioning, lsmod, for instance, for listing all loaded modules. And if you want to do all these things manually, yeah, then you could use insmod, or you could use rmmod for inserting modules or for removing modules from your running system. Yeah. Okay, so this was the tool modprobe. I hope you have learned a little bit about the tools we talked about today. If you have any questions, feel free to leave a comment below the video, or yeah, see you next time. My name is Robert Wolfart, and if you are interested in more such tools like the ones we talk about here, yeah, simply go to shelltoolbox.com and have a look at the Shell Toolbox. All the tools here are taken from my ebook, the Shell Toolbox. Yeah, if you're interested, go to shelltoolbox.com and have a look. Okay, see you next time.